Good afternoon. I'm Mr. Precella. I'm here with my college algebra class, and today we're going to look at zeros of polynomials and synthetic division. Before we look at synthetic division, I want to remind you of what polynomial long division is. Looking at polynomial, here's an example of polynomial long division, and notice it has the little long division symbol there, that just like what you use with numeric long division. And that's usually taught in algebra classes sometime after multiplication of polynomials. The order is usually addition, subtraction, multiplication, and then division. This is the last operation on polynomials that students usually learn. And we're not going to be using that polynomial long division. What we're going to do is use something called synthetic division.
For some terminology,
synthetic division is a shortcut to polynomial long division that can only be used when the divisor is in the form x plus or minus a number. It's a shortcut for polynomial long division that can only be used when the divisor, we'll review that terminology divisor in a moment, when the divisor is in the form x plus or minus a constant k. X is the variable, that k value is a number. Now, there are several different ways of expressing the operation of division. The first symbol that you would have seen to represent division is probably that little dash with the dots. The dividend divided by the divisor equals the quotient. Hopefully remember that the quotient is the answer to a division problem. The thing that's being divided is the dividend. The thing doing the dividing is the divisor. And another way of expressing division is through a fraction bar. In that event, the top thing would be the dividend, and the bottom thing is the divisor. The answer is still called the quotient. So, the thing that's being divided, maybe I should write the little division symbol also, since that example that we had there had that little old-fashioned long division symbol. Here's my old-fashioned long division symbol. The thing that's being divided is called the dividend. The thing doing the dividing is called the divisor, and the answer is called the quotient. Look back at that picture you have up there. In this case, what's the divisor? Is 5x to the fourth plus x cubed minus 3x squared minus 6x minus 8, is that the divisor? No, that's the dividend. Okay. X minus 1 is the divisor. We could use synthetic division to perform this division rather than that long polynomial long division. You know something? Maybe we should do that. Let's perform that division there, that long example you have. Let's do it using synthetic division.
And you can show them the process.
Yes.
Mm-hmm. Mm-hmm. And you say x, what was it? X plus or minus k. You mean x plus or minus a number.
A number, that's right.
Mm-hmm. Because you're going to have to write k equals.
I know that.
Okay.
I'll figure it out.
Okay. Oh, wait, no. Here's the one. Just write down this division problem right here.
Let me write it down. We have 5x to the fourth plus x cubed minus 3x squared minus 6x minus 8 divided by, so here comes the divisor, it's x minus 1. To use synthetic division, the thing being divided, the dividend, has to be in descending order based on exponents, and that's what we have here. The biggest exponent, 4, 3, 2, 1, and finally no exponent, no variable appearing. That's the constant term. What we're going to do is determine what I call the k-value. The k-value is the number that makes the divisor equal 0. What number would make that divisor equal 0? It should be obvious. Okay, so k is equal to 1. And here's a hint. Here's something you'll want to remember. The k-value will always be just the opposite of what you see in the parentheses. You see a minus 1 and negative 1, the k-value is a positive 1. Now I'm going to put some column headings. I'm going to start off with the largest exponent, x to the fourth. You have x to the fourth, x cubed, x squared, x, and finally my constant.
The constant is always the number with no x on it.
Then we got write the coefficients. That's a positive 5, x to the fourth. That's a positive 1, x cubed. What's the coefficient of x squared? Be more specific, more than just a 3. Negative 3, right. X, negative 6, and my constant is negative 8. Oh, well, this isn't a very interesting example. A k-value of 1. Okay, I should have spotted that, but still, you'll see the pattern at least. Skip a line and draw a horizontal line.
If you're using lined paper, this is going to be 4 lines. Okay, you're actually doing this division in just 4 lines of work. Okay.
The first thing you do, you take that leading coefficient, whatever it is, you move it down underneath the line. 5. Then you go 5 times positive 1 gives you a positive 5. Then 1 plus 5 is a positive 6. And I'm showing the positive signs here because those positive signs are going to become plus signs in my final answer. Then I repeat. 6 times 1 is a positive 6.
Y'all see why he's saying it's not very interesting? It's unfortunate that the k-value was a 1. If it were a 2 or a 3, you might see the pattern better.
Because here it looks like I'm just taking this number and sticking it there. No, I'm taking that number times 1, and it just so happens it's that same number. Then negative 3 plus 6 gives me a positive 3. Repeat. 3 times 1 is a positive 3. What am I going to have down here? Negative 6 plus 3, I agree, is a negative 3. What am I going to put here? Okay, negative 3 times positive 1 is a negative 3. Negative 8 minus 3 gives me what? A negative 11.
Now remember, this number is negative 11. Let's look back over here. Do y'all see where there's a negative 11 in this? When we do synthetic division, the negative 11 is the last number. Okay? What about
where do you see negative 11?
Right here. It's the remainder.
It is the remainder. That last number is the remainder. That means x minus 1 doesn't divide evenly into this big polynomial. Because if something divides in evenly, what's the remainder going to be? When we talk about something like 3 divides evenly into 6, because if you take 6 divided by 3, what's the remainder? 0. If the remainder is 0, then the divisor divides in evenly, but the remainder isn't 0. Now let's stop and think. We have a 5x to the 4th, and it's being divided by an x. Here's my scratch work. 5x to the 4th, and it's being divided by an x. I think we can cancel an x above and below. What's that going to leave me as the power on the remaining x? 3? Okay, with that logic, you started with an x to the 4th. Your quotient's leading exponent will always have a power 1 less than the leading term in the dividend. That's an x to the 4th, so down here the quotient starts at x cubed, then it decreases x squared, x to the 1st, that minus 3 is my constant. When we have a remainder, we'll go plus remainder over divisor.
Who else will some of them I think write r equals
Okay.
negative 11. I like that better than on this example here, which was just a screenshot from your book. Notice what they write right here,
I
r
like that
minus
better.
11. You don't like r equals?
I like r equals.
Yeah. I don't like this r minus 11. It should say remainder.
R equals negative 11. It should.
So
I think
there's
they messed up.
two ways to write your answers. You can write them with r equals, or you can go remainder over divisor. How will you do it? However they want you to do it. Okay? But this is a nice shortcut way for division. But of course, it only works if the divisor is x plus or minus a number.
And you're going to see that in many cases, that's exactly what you have as the divisor. So that's not a huge hardship, assuming that the divisor will be variable plus or minus a number. So,
Now let's find one where k isn't a 1.
yeah,
Okay?
let's find one.
Let's see. My notice to do number 4. 1, 2, 3, 4. For some reason, in a previous semester, we did 4 first. Let me see why. Oh, this is a good one.
Okay. Now let me write the problem down. This is number 4. We're taking 3x to the 4th minus 16x cubed plus 18x squared minus 9x plus 4 divided by x minus 4.
I'll go ahead and mention, yes, we can use synthetic division on it because this divisor is x minus 4. It's in the form x plus or minus a number.
Okay, tell me the k value. What will be the k value?
Look at the
I couldn't hear you.
a
Positive 4. Remember, it's exactly the opposite of what you see. You see an x minus 4. You want the number that makes that thing equal 0, so it's a positive 4. And then we have an x to the 4th. Put in our column headings, x cubed, x squared, x, and a constant. Now we go through putting in the coefficients. The coefficient of x to the 4th is 3 here, negative 16 here, okay, a positive 18 here, negative 9, and positive 4. I'll go ahead and put those little positive signs there. We skip a line. What number do we have right here? How do we get the process started? We bring the 3 down. It's a positive 3.
I remember I used to draw a little arrow here, and then one day at the end of the semester, a student told me that they had a question they'd always wanted to ask me, but what was that number I was writing here? And I was just drawing a little bitty arrow.
Like that.
And I was like, oh gosh, why did you wait till the He was through with the final.
That
Tell
looks
me
sort
that.
of like a 1 or a 2.
Yeah,
I don't like that.
So
I'll leave
I'll
it
draw
blank.
an arrow there.
I'll leave it blank.
Okay, now this one's going to show the pattern better.
You
than
take
the 1.
You take the 3 times the 4, that's a positive 12. Negative 16 plus 12 gives me here, negative 4 times 4 gives me a negative 16. What am I going to have here? A positive 2. Do you see why I put the plus sign? Because in a minute I'm going to stick in the variables and circle it as my answer, okay? So that plus sign I'm showing, that positive sign I'm showing, because that's going to become a plus in a moment. What am I going to have here? Okay, positive 2 times positive 4 is a positive 8. Negative 9 plus 8 gives me a negative 1. Times 4 gives me a negative 4. Hey, what's my remainder? Okay, that means x minus 4 divides in evenly. There's no remainder, so x minus 4 divides in evenly to the dividend.
X minus 1 did not divide evenly. Dividing evenly means remainder is 0.
Okay, we started with the next to the 4th. We divided by an x, so there's only 3 factors of x left. And then we sweep through, putting in the x's, x cubed, x squared, x, and finally my constant. There's my final answer. I'll circle it in gray.
Okay, so we'll touch this one in. 3x to the 3rd.
Get out of the exponent, minus 4x squared. Plus, get out of the exponent, plus 2x minus 1.
Okay.
Any questions there?
Sort of see the pattern. This is some of that stuff that I can show you how to do it, but if you wanted to write, could you imagine writing a recipe step by step on how to do synthetic division?
Well, you were gone. I tried to write out a recipe for completing the square for circles, and that recipe didn't go well at all. There was a separate video at the end of class, and I deleted that thing afterwards.
Good. Okay. Let's go back to number 3.
Oh, well, come back here. I think it's a good time for me to mention some terminology. We say that 3 is a divisor of 6. 3 is a divisor because it goes in evenly. 6 divided by 3, there's no remainder. Likewise, we say x minus 4 is a divisor of this stuff here. So, if the remainder is 0 when you perform division, then the divisor is the divisor is a factor. It goes in evenly. That means x minus 4 is a factor, just like 3 is a factor of 6. I think I was still using the word divisor, but 3 is a factor of 6. Just that means, and similarly, x minus 4 is a factor of this stuff here. I'm going to write out, since the remainder equals 0, x minus 4 is a factor of, that long thing, 3x to the 4th minus 16x cubed plus 18x squared minus 9x plus 4. I guess I could have just said x minus 4 is a factor of the dividend. That would have been quicker.
I like it like that.
But I think people
are
are still
writing all your sentences.
Yeah.
Oh, what?
And
Do you 3 now? There. 3 to 3. 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 3 to
Okay, let's do number 3.
1, 2, 3 are all multiple choice like this, and I'm just going to do one at 1, 2, let's do 3. I thought 3 had the best. 3 is the best numbers.
2s cubed plus 13s squared plus 13s minus 14 divided by s plus 5.
If I were ruler of the world, it wouldn't be the first rule I would make, but in the top 10, I would make the rule: you cannot use s for variables in algebra class, because before it's over, an s winds up looking like what? A 5. Okay? And this one's even worse because there's an s and a 5 in here. So, but we can't control that.
K equals...
Oh, wait, let me show what you're writing.
Oh, I try to remember to print my K, but I just by habit use my cursive K. But that is a K there. K equals what? -5. Remember, it's exactly the opposite of what you see.
Or what would make it 0.
See, it's the thing that would make the divisor equal 0. So K equals -5. So there. Then we have s cubed. That's the largest exponent is 3. S squared, s to the first, and my constant. I fill the numbers in going across. Here. 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 And here. And then we skip a line. What do we do to get the process started? Bring down the 2. Good. And then 2 times -5 gives us a -10. Positive 13 minus 10 gives me a positive 3 times -5 gives me a, okay, positive 13 minus 15 gives me a -2 times -5 gives me a positive 10. -14 plus 10 gives me a, okay, do we have a remainder of 0? So is s plus 5 a factor of that polynomial? No. We're going to have a remainder. Well, what's our variable part? Here. S. Okay, s to the second, or s squared, however you want to say it. Then you go down to s to the first, and finally no s's. And isn't this multiple choice?
Yes.
How are they wanting us?
I think it just says R. I'd prefer R equals.
Yeah, R equals -4.
Okay, so it's 2s squared plus 3s minus 2. 2s. Oh, they all look alike.
2s squared plus 3s minus 2. No, I thought it was a, but no, that's not it. I think it's
what's the
C?
difference between C and D? Oh wait, the 2.
Oh, it's D.
It's D. Oh, okay. Oh.
Any questions there?
It's called synthetic division.
It is a shortcut for polynomial long division. It can only be applied though when the divisor, the thing you're dividing by, is in the form variable plus or minus a number. You can't have a 7s or a s squared as your divisor. It has to just be the variable plus or minus a number. Any questions there?
You'll think back way before your time, before calculators, almost before our time, but Think back to the 1940s when there weren't handheld calculators. If you were told, oh, you need to plug -5 in for S on all of these, would that be a pain to do? Plug -5 in for S without a calculator. Pretend you don't have one. -5 cubed, or -5 times -5.
That's a negative 125 times 2. That's a negative 250 plus, well, that's a 25 times a 13.
13
Okay, I
times
give
25.
up.
Can't do that easily in my head. It'd be 10 plus 250 plus
75, 325. So y'all keeping track? What do we have? We have a negative 250 plus 375.
So we're trying to do this in our head without a calculator and stuff.
Minus 65,
it's a little bit
minus
more work.
14.
What about, did y'all have to have a calculator to do this?
Did you wind up having to cube big numbers or anything? No, it's all just addition, subtraction, and a little multiplication, but there's not the messy exponentiation. So, back in the olden days, before calculators, they discovered something. Suppose we took -5 and plugged it into the dividend. Let's see. I don't like that S. Wait a minute. I don't like that S. I'm rewriting this. I'm going to call it a P of X. It's a polynomial function, and it's 2x cubed plus 13x squared plus 13x minus 14. That's the thing that's being divided. I'm getting rid of those S's, okay? Since I'm making this up on my own at this point. This has nothing to do with an answer to number 3. We're through with 3, but I need to use a polynomial. I need a dividend, so it seems to me like that's a good dividend. Suppose I wanted to know, what does this thing equal if we plugged in -5?
You denote that by saying P of -5.
P of -5.
There is a point to this.
We're making a point. So it's 2, 13. Oh, I'm going to write it out for you. Aren't you punching it? I thought you were punching it in.
I just haven't hit equal. By the way, on this calculator, I have a x squared key, but to enter something like cubed, I hit this little arrow top,
Carrot
top, and just a 3. That's what I have. Net 2, parentheses, -5, caret top 3. Let's hit enter and see what we got. -4.
-4, that popped up here somewhere.
Where was -4 pop up?
If you plug in that K value, that thing equaled -4. And where did that pop up?
This remainder.
Right.
Do y'all think that's true? Will that always happen?
If you look, yes, there's something called the remainder theorem. If you take a function and you want to evaluate it, say at a number like -5, if you use synthetic division with -5, that remainder will always equal the value of the function. Looking through real old algebra books, where they have this messy function and they need to evaluate it at something like -17. They didn't have calculators to go -17 times -17 times -17 times 2. What do? They had this little synthetic division matrix set up to get that last number.
You look at old textbooks, you'll see
math
books, algebra books.
You'll see that synthetic division popping up anytime they need to evaluate a function.
Oh, I need to plug this number in. Okay, they do that. Because write out remainder theorem.
I'm going to write it out.
P of K equals remainder.
Remainder theorem.
And it's not that significant now, I guess, with calculators.
It says that P of K, if you plug K into the polynomial you're trying to divide, it will always equal the remainder.
So just do synthetic division and look at the remainder.
But in this day and age with calculators, it's not that significant anymore. But when the state of Texas went through their project student learning outcome, where they went through every undergraduate course that is funded by the state of Texas, and they wrote out, okay, here's what students need to learn in the course. If they're getting tax dollars, they need to be taught this. One of the things that made it onto the college algebra student learning outcomes was the remainder theorem. By name, the remainder theorem is listed by name. There's something called the fundamental theorem of algebra. The fundamental theorem of algebra. You would think that must be pretty important. It's got to be on the list. Nowhere.
Was it on the list?
Nowhere.
Remainder theorem. Okay.
The remainder theorem was listed. And so for some obscure reason, and I know why, I just don't want to say it on the recording, okay?
Right. Let's do number 5.
Let's do number 5. Here it is. They give us a function. They want us to use this remainder theorem and synthetic division to find f of k. So
theoretically, you could get your calculator and plug it in, but let's do it with the remainder theorem because this great state of Texas thinks that this is so important.
I'll be honest. I have a theory for how it made it to the list. I think people were sitting around. I think someone was sitting around. They were sitting around. Oh, what should these students learn when they're finished with their algebra class? And I think somebody, Texas politicians, they don't know that much algebra. They may not know what's important. Okay, so after that, the brief pause. Here's the function. They want us to find the value of this function when we plug in -4 using synthetic division and the remainder theorem. Notice in the previous problems we had to calculate the k value. Notice we had to calculate the k value because they were giving us the divisor, and we said, oh, it's exactly the opposite of what we see there. Here they're giving us the k value, okay? They're telling us straight out that k is equal to -4.
So you don't change any signs.
And we have an x cubed, an x squared, an x, and a constant. We fill in our coefficients here. -2 here, -10 here, -9, and the constant, -3. We draw our line. What goes here? -2. What goes here? Wait a minute. -2 times a -4. Be careful. A +8. Here. Another -2. Here. Okay, -2 times -4. That's a +8. Here. -1. Here. +4. -1 times -4 gives me a +4. Down here, a +1, and there's the answer. If we had gone through and plugged in -4 for every one of those x's, we better get +1. Y'all think that's right? Let's see. Tony was punching it in there, so let's see. Is it going to get... Sure enough, there's the calculator. It's giving us a +1.
Let me punch that in.
And the advantage is, if you didn't have a calculator, -4 times -4 times -4 times -2. Here, there's no exponentiation to deal with. Oh, you have to multiply, but it's not -4 times -4 times -4 times -2. And you have to add and subtract. But there's not that exponentiation, that time-consuming exponentiation. And notice the numbers stay small. If you had -4 times -4 times -4, that's a -64 times a -2. That right off you get a +128. So you're working with larger numbers.
Mm-hmm.
But then again, in this day and age, I don't know that it's that relevant.
What was the answer? +1?
+1.
Okay.
And remember we said that that number right there is the remainder. We said that if the remainder is 0, then the divisor is a factor. It divides in evenly. We have the factor theorem. We have the remainder theorem that says that that last number there is the number you'd get if you plug in the k value. We have the factor theorem. Well, first of all, I better define the name of what we're using right now. The name of this section is Zeros of Polynomials. The name of the section, Zeros of Polynomials and Synthetic Division. I'll say k is a 0 of the function p of x if p of k is equal to 0. A 0 is a number that you can plug in and make the function equal 0. If you plug the number in and you get a 0, then we say that number is a 0. There's another word that used to be used when we were in school. The books called these things roots. K is a root of p of x, but that terminology has been pretty much eliminated now. And why?
I think square roots, cube roots. Why do we need another root?
They're not the same thing as a square root or a cube root.
Should you go ahead and
I think a 0.
4 remainder equals 0?
Yeah, you're right. The remainder would have to be 0.
So if the remainder is 0, or you plug in the number and get 0, it's the same thing. Okay?
And
like if negative 4 is 0, algebraically, could we say this k value is
it a 0? Did it make that function equal 0? No. Let's see. I know we saw 1.
Right here.
Number 4.
Is this k value a 0?
Is 4 0?
Yeah.
Yes, it made that function equal 0. It gave us a remainder of 0.
Right,
what about 1? Was 1 a 0?
Is k equal 1? Is that a 0 of the polynomial?
If you plugged in 1 up there, would you get 0?
No. That's why I like just R equals rather than this fraction notation that you sometimes see students write.
Okay, so a 0 or a root is a number you can plug into the function and make it equal 0. At the same time, the remainder has to be 0. The factor theorem says if k is a 0, then x minus k is a factor. That agrees with our terminology that we use involving division. If something divides in evenly, we say that something is a factor. So if I know a 0, if I have a k value, I can determine the factor, realize it's the factor is going to be exactly the opposite of the k value. It'll be x and exactly the opposite of whatever that k value is. So there's a negative 4, well, it'll be x plus 4. Here, it's a negative 5, so the divisor would be variable plus 5. They're now going to start giving us the k value, and we have to go back to the divisor. Is that clear? Okay.
And let me go ahead and just show them what problem problem 6, 7, and 8. We're going to do something we haven't done this semester. We factored
x
squares, like negative 5x squared minus 23x plus 6. We factored quadratic expressions, but we haven't factored anything with the x cube, have we? We factored things with 3 terms.
But we have not factored things with 4 terms. What we're doing here with synthetic division and the factor theorem, we are going to develop a procedure that we can use to factor higher order polynomials. That means things higher than x squares, x cubes, x to the fourths. That's what we're trying to get here, is a strategy for factoring polynomials. it doesn't matter how big the exponents are, there is a drawback. In order to use this process, you must know a zero. You have to know a number that can be plugged into the function to make it equal 0 in order to get it factored.
And it's going to turn out it's not really that hard to find those numbers.
It's not really that hard to find those numbers, okay? But here, on number 6, they're just telling you the k value automatically.
So if we're going to factor something with 4 terms and an x cubed, your answer is going to have 3 sets of parentheses. So this might be the first time you've ever factored anything with 3 sets of parentheses. Normally we have the quadratics,
and it's only 2 sets of parentheses. That's what we've seen so far. But
3 x cubed, we're going to factor something with 3 sets of parentheses here.
Factor f of x into linear factors, given that k is a 0 of f of x. I want to mention something before we go on. I want to mention the division algorithm, okay? The division algorithm says, that if you have your dividend divided by your divisor equals quotient, I'm going to rewrite this as a multiplication problem. Realize that, didn't you learn multiplication before division? Think back just in terms of some simple numbers. We say 10 divided by 2 is equal to 5. 10 divided by 2 is equal to 5. Why is that? Because 2 times 5 is equal to 10. That's the division algorithm. The dividend times the quotient, the divisor times the quotient has to equal the dividend. The divisor times the quotient is equal to 10. Why do we say 10 divided by 2 is equal to 5? Because 2 times 5 gives you 10. You're asking yourself, 2 times what gives you 10? That's the division algorithm. And I'm going to write it out in words. Dividend divided by divisor equals quotient means the divisor times the quotient will equal the dividend. I was going to do an example and then write out the strategy. We have a little guideline that we use for the strategy for factoring higher order polynomials. I think we'll do an example and then write out the strategy. I'm hoping if you see an example first, then that little general guideline will make more sense, okay? So this is number 6.
Keep in mind, your final answer is going to look like 3 sets of parentheses that you can start foiling out and eventually end up with 4x cubed minus 5x squared minus 23x plus 6. Okay?
And they tell us that k equals 3 is a 0.
In order to do this factoring the way we're going to do it, you've got to have one of those zeros given to you.
Or be able to figure out one. Okay, go ahead. Oh, I used my cursive K again. Y'all can, that's a K.
It's like an R to me. Okay.
It sounds like someone's jealous of my penmanship awards there.
Well, I can clearly tell that this, if Miss Matoya were still alive, I'd send her this penmanship of yours, and I think she would revoke your penmanship.
Oh, goodness. Okay, so what we're going to do is we're going to use this 0 to break this function down so that it's quadratic. Now, our goal at the end, we're going to have this thing is equal to, we're going to have parentheses. We want 3 sets of parentheses. I already know one of the parentheses because they gave us that k-value. Remember I said that whatever the k-value is, what you see inside the parentheses for the divisor is exactly the opposite. You see a positive 5, but the k-value was a negative 5. So I see a k-value of positive 3, so the first divisor, the first factor, is x minus 3.
So you already have one of them, so now we just need 2 more.
We need 2 more factors. We know one of them, x minus 3. Let's use synthetic division, and once we do, then I'll bring up that division algorithm and you'll see where this is all going. Let's set up, we have a k-value of 3. K equals 3. And I have an x cubed, an x squared, an x, and a constant. No, they gave you the k-value. They gave you the k-value. We're going, look, the factor is x minus 3, but remember when you look at a factor or a divisor, you change it to get the k-value.
When you're losing the x, you drop the sign changes.
Yeah, when you're losing the x, you're right, then the sign changes. So we have a 4, a negative 5, a negative 23, and a positive 6. Oh, and by the way, if one of the terms were missing, say you had x cubed and no x squared, then in that place right there, the coefficient is 0. You don't have an x squared. So if a term is missing, when you started at x cubed, you have to fill in the rest of the spaces. If there's one missing, you assume a 0. You bring down the 4 times 3 is a positive 12. Negative 5 plus 12 gives me what? A positive 7 times positive 3 gives me a positive 21. Negative 23 plus 21 gives me a negative 2 times 3 gives me a negative 6. 6 minus 6 gives me a remainder of. Is that surprising? Should we expect that? Yes, because they told us k equals 3 is a 0. That means if you plug in 3, you're going to get a 0. So that's not surprising. If you hadn't gotten a 0, then we'd have a problem. You couldn't factor it then. So what's our quotient? What's the variable part here? Started at an x cubed, you divided it by an x. So x cubed divided by x, x squared, and then an x. There's my quotient. So we're trying to factor f of x. F of x is equal to, remember the division algorithm. The division algorithm says dividend divided by divisor equals quotient, means that the divisor times the quotient will give you the dividend. So f of x, the dividend, the thing we're dividing, is going to equal the divisor. We know the divisor is x minus 3. It's exactly the opposite of that k value that they gave us, times, here's the quotient, 4x squared plus 7x minus 2.
Now, is that
4x squared plus 7x minus 2.
is in this quotient here, this 4x squared plus 7x minus 2, is that no good? Separate. Is that something you now know how to factor with trial and error? Is this a quadratic expression here?
This is the stuff we've been factoring since the second week of the semester, isn't it? It's a quadratic expression. We know how to factor that. We're going to have to write our 2 sets of parentheses and use trial and error. So, We're trying to find those other two sets of parentheses. That's what we're looking for. Once we factor this green stuff, is it going to be in two sets of parentheses? So by knowing a zero, we're able to determine one factor automatically. Use synthetic division. Here's another factor. We need to factor this further. So let's factor 4x squared plus 7x minus 2.
This is a good little example of factoring. 4, we have 1 times 4 or 2 times 2. But you know what? Why don't we fill in the 2 first?
We know that 2 is going to have to be a 1 times 2. Do you agree there? There's no other possibility. 1 times 2. We're going to have to 1 and a 2. Applying the logic, remember you can't have a common factor in parentheses. 4x squared, well 2x and 2x. If you try to use 2x and 2x, what's going to happen here? Give me a pencil. I know I had a pencil out earlier. Right there. Okay. I'm going to erase it. Don't write that down. But if you tried to put the 2x and the 2x, then you're going to be pairing a 2 and a 2. Is that okay? No. So 2x and 2x cannot possibly work.
Well, what about 1 and 4?
Could I put the 4 here? Could I put the 4 there? No, because 4 and 2 are both divisible by 2 again. So if we're going to use 1 and 4, if this thing is factorable, we better have the 4x here and the 1x there. I forgot to ask y'all what we know about the signs. Okay, the last sign's a minus, so you have 1 positive and 1 negative, and play it out in your head. You want to get a positive 7x. What should I have here? A negative and a positive. I agree. Let's check. Let's check. What's the outer product? Here I am checking. The outer product.
Checking, you're
4x.
foiling it out.
I'm foiling it back out. Well, I know 4x times x is going to give me 4x squared. So the outer, what's the outer product?
8x.
8x. What's the inner product? Negative 1x. 8x minus 1x, that gives me a positive 7x. Is that what I needed? And I knew the last times last was going to give me a negative 2. I would have written it down there if it didn't. So this is the correct factorization.
So is that what I type in?
No, you have to type, here's the first factor that we knew. We still have 4x minus 1 and x plus 2. Here's the final answer. I guess I left too much space there.
Okay.
That's okay because we went and bought ourselves a new notebook to use, so I can write as big as I want. We have plenty of paper to last the rest of the semester.
So imagine, wow, could y'all think of drawing 3 sets of parentheses and doing trial and error and coming up with
this answer here, x minus 3 times 4x minus 1 times x plus 2. I think that would just be next to impossible, just use trial and error. But if you know a zero, you can take a higher order polynomial and break it down until you get something that you can factor by trial and error.
So let me punch that in.
It's a little mind-boggling what we can do now. Oh, and remember the order of the factors doesn't matter. If you wanted to type the 4x minus 1 before the x minus 3, that's perfectly fine. You just have to have the same thing inside all 3 sets of parentheses.
Is that a plus 2? Yeah.
Yes.
Type it right. Yeah. Now do you want to write my little...
Okay, so now I'm going to write... Okay. To factor a polynomial.
Here's our little strategy. I think write it down here so you can show them that you're doing exactly what you did there.
I thought write it over here so they could be following us to do another example.
Oh, okay. Okay. You're right.
Oh, okay. And you know I write big. So, to factor a higher order polynomial.
You mean something other than just
a square.
If it's quadratic, just do trial and error.
Yeah, but okay. So to factor a higher order polynomial, when you know k is a 0, first thing you'll do, use synthetic division. Use synthetic division. You're trying to find the quotient.
Goal is going to be to get 3 sets of parentheses. One of the sets of parentheses is always
the variable and the opposite of the k value. So step number 2, x minus k is always a factor. X minus k, put in parentheses, yeah.
So that gets you one factor. After you've used synthetic division to get the other 2.
Well, let's see. Let's look at what we did. So we've already done a chunk of this. We used synthetic division, okay. That gave us the quotient. Then x, and then the opposite of the k value, that was a positive 3, so x minus 3, that was one of the factors. And then, what did we do once we got here? Use trial and error to factor the quotient.
Yeah.
So how would I say it? Use trial and error.
Trial and error to factor the quotient. And just one final answer.
Okay, how about in this? And that's assuming that you're factoring a polynomial with that's x cubed. Now, if you're factoring a polynomial that starts off at x to the 4th, how many sets of parentheses do you think you're going to have? 4, okay. And so
that's sort of the fundamental theorem of algebra.
That fundamental theorem of algebra. Now, remember, hey, now that we factored this thing, I'm going to come back over here. We knew that 3 was a 0. We knew if you plugged in 3 here, you were going to get a 0. They told you that. If you plug in 3 here, then you're going to get 0. 0 times 11 times 5. It's going to give you 0. There are 2 other zeros. What number can you plug in here to make the thing equal 0? Once you have it factored, not only do you have it factored, written as a product, it's easy to determine the remaining zeros. They didn't ask us this, but what number, look at this one here. What number would you have to plug in for x to make that equal 0?
I'll give a hint. It's not positive 2, it's
negative 2. So there's a 0. And there's another one. We already said, by the way, that 3 was a 0. What about this one? Okay. We move the 1 over. That gives us a positive 1. Divide by 4. There's the third 0. What the fundamental theorem of algebra says is that the number of zeros you get cannot exceed the largest exponent.
And it's usually equal to.
Mm-hmm.
Usually if you have an x, just think like with the quadratic formula. If you have an x squared, you usually have 2
answers.
And so x to the 3rd,
you usually have 3. Now, well, how would you only have 2? I said it's usually I mean, you'd have no more than 3 in this case. Well, suppose it had been x minus 3 times 4x minus 1 times x minus 3. If you had repeated factors, then you would have fewer than 3 zeros. But the fundamental theorem of algebra says that the number of zeros cannot exceed the largest exponent. Hey, is there another number I could plug in up here and make it equal 0? Maybe
Sure.
I could plug in 17 million here to make it equal 0. You think I can do that?
No.
No. We know the number of zeros can't exceed 3. We found the 3 zeros. Here they are. 1, 2, 3. I could just go on and on about this all day.
Theory
But
of polynomials.
yeah,
But let's do number 7 instead without anything superfluous.
I'm not going to say anything that's unnecessary.
Except I'm going to say one thing.
Oh, no.
There's a letter missing on this. On number 7, they don't say k equals blank is a 0. You've got to know that where it says is a 0, what's the k value going to be here? Nope, don't change it. You only change it when you're writing the factor. When you're writing just the
the K value is the number itself.
It's sort of unfortunate. Look, here they
K.
said K is a 0, K equals. On number 7, does it say K equal negative 6 is
You
a
have to
0?
know. You have to know that negative 6 is going to be your K value. And look at how I wrote it
I
down
think
here.
7 and 8, neither of them say K equals. You see up here, on number 8, it doesn't say K equals. But have you written it
Switch it
down?
around.
Oh, you ready to do it? He's just going to, okay.
I saw that negative 6 was a 0. I automatically wrote it as my K value. So I have K equals negative 6.
You're doing step 1, the synthetic division.
I have an x cubed, an x squared. These are my column headings and my constant. I have a 4, a positive 15, a negative 52, and a positive 12. Oh, this is rare. I've gotten hot in here. I think it's just because that coat is thick. Okay. Skip a line. What do I do first, or what do I do next? Bring down the 4. So I brought down the 4 times negative 6 gives me a negative 24. 15 minus 24 gives me a negative 9. I agree. Times negative 6 gives me a positive 54. Negative 52 plus 54 gives me a positive 2. Times negative 6 gives me a negative 12. And look at what I'm getting for my remainder. A 0. And I knew I was going to get that because they told me that negative 6 was a 0.
Haven't gotten a 0, you messed
You've
up.
messed yeah.
So this is a nice way to check and make sure.
So we're finding our quotient. What's the variable part here? X squared. It's 1 less than the power, the largest exponent in the function, then x, and finally no x.
Why don't you just draw your 2 parentheses and factor it right there.
Okay, I could do
I was
that.
about to say,
But I'm going
the
to...
same stuff we got. You
I'm
draw
going to
your
come
3
to...
sets of
I know,
parentheses.
I got to draw my 3 sets of parentheses.
What goes in one of the sets of parentheses? X minus k. So it's x
Minus a
negative
negative 6. So what is that going to be? That's the blue one right there. That's going to give me...
Oops,
What is
there?
it? Not x minus 6. It's x plus
Yeah,
6.
minus and negative. It's when you're going from k equals to x.
That you change the sign.
You might say, well, why didn't we change the sign when we got started?
We
it just
already
said
had the
negative
k-value.
6 is, it didn't say,
The 0 is the number that has to be there in the little hook. Negative 6 is the 0. That k-value is the 0. Well, now we need to factor 4x squared minus 9x plus 2. Let me write out my two sets of parentheses.
hey, can you fill in the signs right now?
Oh, this is nicer than the other one. What do we know about the signs? Okay, the second sign's a plus, so you have two of the first signs. And I think we can apply the same logic, because we still have that 2, just like we did in the previous one. You're going to have a 1 times 2. Can you put a 2x into 2x to get 4x squared? You're going to have to use a 1x into 4x. Can I put the 4x here? No, because then 4 and 2 are both divisible by 2. So we'll put the 4x here and the 1x there.
There's your two sets of that.
Let's just verify it. 4x times 1x is 4x squared. Outer, 4x times a negative 2, that's a negative 8x. Here I am on my scratch work, just checking. What's my inner product going to be? Negative 1x, negative 8 minus 1 is a negative 9x. Is that what I needed? Yes, it is. And then last times last, well, that obviously gives a positive 2. I wouldn't have written it down if it didn't give me a positive 2. So I have two other sets of parentheses, 4x minus 1 and x minus 2.
Your answer is 3 sets of parentheses. The order in which you write them or type them in doesn't matter.
Why don't you start at this one and type them in the other direction? Type in the x minus 2 first.
X minus 2, close parentheses, open parentheses.
4x minus 1
X minus 1, close parentheses.
and x plus 6.
Plus 6. A nice way of factoring a third-degree polynomial. Still got to know that 0, but we'll show you a way to find those zeros in a moment.
Switch over to this one once more. We already know one of the zeros. We knew negative 6. When is x plus 6 equal to 0 at negative 6?
So there's 1 0.
When is, let's find the other two zeros. There are two more zeros. When is 4x minus 1 equal to 0? 1 over 4, I agree. What's the last 0? When is x minus 2 equal to 0? When x is positive 2. When does x minus 2 equal 0? When x is positive 2.
Hey, what about 7? If I plug 7 in here, would it give me 0? No. If I plug the fraction 1/5 in for x, would it give me 0?
No. There can be no more than 3 zeros.
And we've
because
found all 3 of them.
the biggest exponent is a 3. You can't have more than 3 zeros. We've found all 3 zeros. So we know a lot here now. We know a lot. We know how to get it written as the function to get written as a product, but we also know that, what about 17,459,000? If I plug that in for x, am I going to get 0? No. These are the only 3 numbers in the whole universe that you can plug in and make that thing there equal 0.
Wow. Such a huge deal. One more of these before we show y'all how you can find those.
Or a finite list of numbers that might be zeros. Let's look at number 8.
Synthetic division, factor the quotient, and then x minus k is 1, 0, and
5x squared minus 4. Okay, 3x cubed minus 5x squared minus 48x plus 80 is the function we want to factor.
No, just
and they tell us that
negative
4
equals just negative 4.
Negative 4 is a 0.
See, they didn't say k equals. You've got to know it. If it's a 0, then that's k.
That's the k value. K equals negative 4. So we set up our synthetic division tableau, matrix, just set of numbers, whatever you want to call it. And the largest exponent is once again a 3, x cubed, x squared, x, and finally a constant. Is that green showing up? Well, I don't think so. So, provide our coefficients. 3, negative 5 here, negative 48, okay, and a positive 80. We skip a line. We bring down the 3 times negative 4 is negative 12. Negative 5 minus 12 gives me negative 17. Negative 17 times a negative 4. Is that giving me a positive 68? I'm getting a positive 68 in my head. Negative 48 plus 68 gives me a positive 20. Positive 20 times negative 4 gives me a negative 80. 80 minus 80 gives me,
mess up, Tim.
because I got a 0 right there. What's the variable part in the quotient here? It's 1 less than the biggest exponent in the dividend, so x squared, x, and then my constant. Here's my quotient. I now need to factor it using trial and error. Oh, we have something nice about the signs once again. There's not one of each. Where does the plus go? Where does the minus go? What do I know is going to be inside those parentheses? Okay, the last sign's a plus, so 2 of the first sign is a minus, so we have a minus and a minus. 3x squared. Only 1 times 3, there's only one possibility there. 1x times 3x.
Oh, a lot for 20.
Oh, there's a lot for 20, so let me write down possibilities. 1 times 20, 2 times 10, 3 doesn't go evenly, 4 times 5. Hey, I've got them all because now we're up to 5, so we'd be repeating. So what do we want to try? 1 times 20, 2 times 10, or 4 times 5? I think that, did you say 4 times 5? I think that's the one we're going to want to use. So I'm playing it out in my head. I think we're going to need a 4 there and a 5 there. I'm playing it out in my head, just meaning I'm imagining if I put the 4 there and then FOILed it out. So let's see if that's right. Let's check. Well, first times first, x times 3x, that's obviously 3x squared. We wouldn't have written it down if it didn't give us 3x squared. We got to check the outer and the inner. What's the outer product? Negative 5x. Here's my scratch word. What's the inner product? Negative 5x minus 12x is a negative 17x. Is that what we needed? Yes, it is. And then you say last times last. Well, obviously that's a positive 20. You wouldn't have written it down otherwise.
Hey, but you just draw 2 sets of parentheses, right? A set of parentheses, right? Here.
So here's my scratch work. Let me move this away. And So there's 2 of the 3 factors. So it's going to be 3 factors because that x cubed. What's the other factor? It's the one I normally write first. Okay,
Yes,
good.
x
If you
plus
take that
4.
0 and you change the sign, they see a -4, so make it a +4. There's, doing it like this, it doesn't look like a long process, Tony.
That looks really good.
Mm-hmm.
I'm not sure if you're looking at the final.
These two factors came from the quadratic that we got after using synthetic division. This one came from the 0 they gave us. Any questions there? So we know -4 is a 0. What other numbers are zeros? What would make x minus 4 equal 0? Positive 4, okay. What would make 3x minus 5 equal 0? You'd have to move the 5 over and divide by 3. What would you get? Positive 5 over 3. So in addition to that -4 that they gave us, there are 2 other zeros, positive 4 and positive 5/3. Are there any other numbers that I could plug in to make this thing equal 0? No, we've got all 3 of them.
Amazing. This is really...
Mm-hmm.
Huh.
But how do we know that we've got all of them? Because the fundamental theorem of algebra says the number of zeros cannot exceed the biggest exponent.
And counting, I've seen the fundamental theorem of algebra worded, counting repetition, the number of zeros
Must equal.
And the only way it'd be less than 3 would be if it was x plus 1, x plus 1.
If you have repeated factors.
So
Yeah.
counting the repetition, it's equal.
Okay, go ahead. Type it in.
Oh, yeah, I forgot. Is it ready for you to write out how to find those zeros? So it was x plus 4, x
Minus 4.
4, and what was the other one?
3x minus 5.
3x minus 5. Close parentheses. Well, how do you find...
Suppose you don't know a 0. Suppose that you have this polynomial, you need to get it factored, and you need to, but you don't know a 0. If we didn't know that -4 was a 0, how would we go about finding a number? We just blindly guessing. Well, maybe 7 makes it equal 0. Maybe -2 makes it equal
Maybe
0.
4/3 makes
Yeah, maybe the
0.
fraction 4/3. We don't know. There's something called the rational zeros theorem. And what it does, it tells us a finite list of numbers that could possibly be zeros. Usually it's about 20 possibilities. So the rational zeros theorem, says any rational zero.
I'm going to give some terminology. We've already said that the constant term is the term that doesn't have an exponent. A variable on it, like 80 would be the constant term. This first coefficient, the coefficient with the biggest exponent, that's called the leading coefficient. Leading is first. So we have a first coefficient, and
that first
constant.
coefficient is the leading coefficient. The thing that doesn't have a variable on it, that's the constant.
Just to make sure. Okay, now you can go ahead and write out.
But understand what this does. It doesn't tell you what the zeros are. It gives you a finite list of numbers. So, okay, here's a finite list, usually about 20 numbers. And these are the only numbers that could possibly be zeros. So if you needed to find a zero, well, take the first one. Either use synthetic division or plug it in to see, does it make it equal zero? If it does, then great. Go on to synthetic division to get it factored. If it doesn't, you go on to the next number. What this does is give a finite list of possible zeros. I'll say it gives a finite list, so at least you have a starting point. It gives a finite list of possible rational zeros.
By rational, we mean whole numbers or fractions. It's not going to give you something like square root of 2 or something.
But when you're factoring something, do you expect, if you set the factors equal to 0, do you expect to get a square root of 2? If you wind up with something like that, then it's not factorable. Okay? So this gives a finite list of possible rational zeros. Any possible rational zeros must be in the form. It's a fraction. We're going to take care of the signs with the positive and negative. You have a plus minus, and it's going to be a fraction. On top, any number on top has to be a factor of the constant term. Factor of constant term. On the bottom, that number must be a factor of the leading coefficient. Any number that could possibly be a zero has to be in the form factor of the constant term on top, factor of the leading coefficient on the bottom. And I don't want to go on to that other one. I want to look, I'm not going to do number 8, just because 80 has a lot of zeros. But number 7 I think would be a really good one. I think number 7, then we'll look and see. We already know the zeros.
Good one.
I know.
Okay, so Tim, write out the example. He's going to say, find the possible rational zeros. Write out your problem.
I am. I'm so glad you're here telling me what to do. Example, find the possible rational zeros of, and okay, f of x equals 4x cubed plus 15x squared minus 52x plus 12. We'll look at the examples in the homework in a moment, but do I have a brain tumor?
If so, it's both of us. I smell something so good.
What is there? Do they have automatic air fresheners in here? Do y'all smell something? Did someone spray? It smells so good. Y'all need to, whoever it is needs to spray it regularly. Okay. Oh God, that smells good. Okay. I forgot. I know. Possible rational. Why are y'all distracting me? Okay. We only have to use 2 numbers in this problem. We have to use the constant term. There's the constant term, 12. 12 is the constant. And according to the rational zeros theorem, we need to use the leading coefficient. 4 is the leading coefficient. So, the possible rational zeros, they'll be positive or negative. We need all the factors of, the last number is what goes on top. We need the factors of 12. And on the bottom, we need the factors of the leading coefficient. factors of 4.
So write out the factors of 12 first.
I'm going to write them out right here. 12. Well, we could have 1 times 12.
What other numbers divide evenly into 12?
2 times 6. And 3 times 4. So those are all the positive integer factors of 12. You say to yourself, well, negative 2 times negative 6 gives you 12. That's the purpose of the plus minus symbol. Don't worry about the signs. The plus minus is going to take care of things like, well, negative 1 times negative 12 could give us a positive 12. You don't have to worry about the signs. Now we need the factors of 4. Well, I'll get us started. There's 1 times 4, and there's 2 times 2. You don't have to repeat it. That's it. 1, 2, and 4. They're the only positive integers that divide evenly into 4. Now we need an organized way of going through and coming up with every possible combination. You have to take every number here and put it over every one of these numbers here. You have to take 1, put it over those numbers. You got to take 2, put it over those numbers. 3, put it over those numbers. You have to go through the entire list. You need an organized way of going through every possible combination.
I would go with every one of these over 1.
That's what I'm going to do. Okay. That's what I'm going to do. I think that's a good way of doing it. I'm going to take every one of the 1, 2, 3, 4, 6, 12. Put them over 1.
And you're writing all of this out for illustration purposes. After a while,
I'll clean all this up in a moment. So then I need to take all of these numbers, put them over 2. So I put them over 2. I need an organized method of writing out all of these possibilities. And then I got to take every one of these numbers here and put them over. I took them all and put them over 1. I took them all and put them over 2. Now I need to take all those numbers, the factors of 12, and put them over 4. I agree. So, and then we're going to go through simplifying. There will be a lot of repetition. I think there will be a lot of these that we can mark out. So it looks like a huge list of numbers, but once we clean it up, I think there won't be that many. I think we'll get it down to maybe 20.
Well, there's only 18 right there, Tim. Oh, that's going to be like, what? Plus
36.
minus.
I was about to say, you need to check your algebra, Tony, because I think we have 36 possibilities right now.
So this first row just simplifies plus minus 1, plus minus 2, plus minus 3. So we're going to go through each one of these rows, simplifying these fractions.
And I think we can drop all the over 1s. Do you agree? So here we go. That'll be a plus minus 1, 2, 3, 4, 6, and 12. So we took care of all of these. Okay.
Why don't you write these out in red or something?
Okay. Okay. The black numbers came from the first row. Now the second row. 1 over 2, 1/2. Do we already have a 1/2 written? No, we don't. So let's add it to our list. 2 over 2. 2 divided by 2 reduces to what? 1. We already have it, so mark it out. 3 divided by 2. 3/2, we don't have it, we better add it to our list. What about 4 divided by 2? That's 2, we already have it, so we don't have to write it again. What about 6 divided by 2? 3, we already have it. 12 divided by 2. 6, we already have it. Okay, now I'm going to use, I want something that stands out a whole lot, so I'm going to use green. Hopefully this is a good green one. Okay, the fourth line, 1/4, 1/4. Do we already have 1/4? No, so add it to the list, plus minus 1/4. 2/4. That reduces to 1/2. We can mark that off. 3/4, 3/4. Do we already have it? No, okay. 4 divided by 4? We already have it. That reduces to 1. Mark it off. What about 6/4? That'd be 3/2. Do we already have it? We sure do. Mark it off. 12 divided by 4. That's 3. We already have it. Out of infinitely many numbers that can make this function equal 0, we've narrowed it down to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So in this case, there were exactly 20 numbers that could possibly be 0. So if you needed to factor this thing and you didn't know a 0, well, let's start off with the positive 1. Use synthetic division. If you get a 0 as the remainder, great. Start using trial and error. If not, go on to -1. Just start going through this list until you find a number that makes the function equal 0.
We look at problem 7.
This is the function from problem 7 that we factored. We found the 3 zeros.
The
Here they were.
-6 was the one they chose to use from the list. They could have used a 2. I don't think you'd want to use a 1/4.
I don't think you'd want to use a 1/4 either, okay? If you're trying to find a 0,
Test the
integers before you even consider the fractions. But these numbers had better be in that list of possible zeros, are they? Was -6 in that list? It sure was, right there. What about 1/4? Was 1/4 a possible 0? Yep, there it was. And the last one, 2. Was 2 in the list? Yes, it was.
So
we're going to take the policy that our esteemed former chair, Dr. Kirkendall, used. He would have the students, he'd show the students, okay, how do you factor it once you know if they give you a 0, right? Okay, how do you factor something when you're told a 0? He'd then tell them, okay, here's the rational zeros theorem. How do you find a list of possible rational zeros? Okay, we found the list of all possible rational zeros. We're going to make the assumption if there's ever a time when, I have this polynomial, I need to factor it, and I have no idea what a 0 is, you'll be able to apply the rational zeros theorem to come up with a list of possible zeros, then go through the process. We're not going to make you do that, the whole thing. We're showing you the pieces, and we expect you to be able to perform those pieces, but we're not going to make you go through the whole process. Here's the polynomial. Find the list of rational zeros. From that list, do the synthetic division until you find a 0, and once you find a 0, assuming there is a 0, then factor it the rest of the way. We're not going to make you go through.
Tim, let's do one of these. Let's do number 10. It's multiple choice. There.
Okay. Let's do. You're not going to have to be typing in all the plus minuses and stuff. So here's number 10.
Multiple choice.
But I can tell some of them are worried about having to go through the whole process. And no, you're not going to have to. We're showing you the pieces. And
I remember the semester the student asked me, there's no view and example on, there's just a few of these problems where there's no view and example. And she was so sincere when she said, how are we supposed to know how to do it when there's no view and example? And I was like, well, I'm just sort of kind of thinking maybe you just look at what I've done in class and do it that way. Oh. There's not very many of these problems where there's not a view and example, but this is one. Okay?
Okay. I've written it down. Have y'all written it down? We want to find the possible rational zeros. Suppose I did this. Suppose I changed that to 661x. Is that going to impact the possible rational zeros? Am I going to use this number here?
For anything?
Suppose I miscopied this and made it a 56 instead of a 66. Would that throw off my answer? What are the only numbers we use for determining possible rational zeros? The first one and the last one, the constant term and the leading coefficient. So let's write out the factors of 27 first.
Notice how you do that first
because that's what goes on top. Okay, what numbers divide evenly into 27? Well, there's 1 times 27. Any more? What times what gives you 27? 3 times 9. And I think that's it. There are 4 factors of 27. Now the factors of 3.
Skip some room. Let's write factors of 3 and then we'll try it with the arrows.
Do you mean like 2 lines?
Yeah.
Okay, what are the factors of 3? 1 and 3, that's it. So we're going to have to take every one of these numbers here, every factor of 27, put them over 1.
Draw a red arrow from that.
Tony's trying to be lazy here, you know. Oh, there.
Showing 1 over 1, 3 over 1, 9 over 1, 27 over 1. Instead of writing them all out, we could start off 1 over 1, plus minus.
So we have plus minus. 1 over 1 is 1. Oh, use red. You're right. Plus minus. 1 over 1 is 1. 3 over 1 is 3. What's the next one? 9 over 1, which is? And 27 over 1. So we put all 3 of those numbers over 1.
Just trying to avoid having to write out all of the fractions. Do y'all see what I did? Maybe that wasn't a... Now let's use a different color.
Okay.
Black arrow.
The black arrows, okay. Now we got to take every one of these numbers and put them over what? 3. Got to take 1 over 3. 3 over 3, 9 over 3, and 27 over 3.
This is a bigger mess than
So we have, well, it's what you wanted to do, Tony. That wasn't my idea. So plus minus 1 over 3. What's the next one? 3 over 3 would be 1. This was a terrible one. We're going to have to do another example in a moment just to make up for this messy thing. 3 over 3 is 1. We already have it. What about 9 over 3? That's 3. We already have it. 27 divided by 3? 9. Look at that. Here.
It's a little messy, but there's less. Did y'all follow that? Or do you only follow it if you know what you're doing?
If you know what you're doing, you can follow it. You go home and show this to our sister and ask her, what do they do? What's going on here? I can assure you, I know what she would say.
Yeah.
Okay. So, 2, 4, 6, 8, 10. Out of infinitely many numbers, there are only 10 numbers that could possibly make this function equal 0. And so, it's a very nice method of getting a finite list of numbers that could possibly equal 0.
Which one is it?
Oh, by the way, the order doesn't matter. Just make sure every number is listed.
That might not be...
They may not have it in the same order. I think it's A. Okay, 1, 3, do they have 3? 9, 27. The only fraction is 1/3.
Yeah, it's
I think
A.
it's A. I think what they're doing is they're taking 1 over 1, 1 over 3. 3 over 1, 3 over 3. 9 over 1, 9 over 3. 27 over 1, 27 over 3. I think that's how they're getting it.
Okay. Well,
Y'all want to see another one, or do you think that we've... do you see the pattern?
let's see. What about
What do you
number
think?
11? Oh, let's do this because that little negative in front of the 2 doesn't change anything, okay?
That plus minus takes care of all the sign changes,
Don't
okay?
bother looking at any signs.
Okay.
Just put plus minus at that piece in front of it.
Negative 2x to the 4th
Yeah.
Plus-
Plus 18.
4x cubed plus 5x squared plus 18.
There's actually, I think there's 4 choices. You just don't see them.
What are the 2 numbers we're going to use to determine the possible rational zeros? Okay, 18, and you don't have to worry about the negative. It's just the 2. The plus minuses take care of all those sign possibilities. So we need, first of all, the factors of 18. There's 1 times 18, and 2 times 9, and there's one more. 3 times 6.
Yeah.
Mm-hmm.
Okay, so this one's going to have more than the one we just did, doesn't it?
And now we need the factors of 2. Don't worry about that negative. That'll be taken care of with the plus minus possibilities. So the factors of 2.
So I'm assuming we're not going to do my little arrows.
What little arrows? I don't know what you're talking about, Tony. I decided that those never existed. I'm writing them out of continuity. You take every one of the factors of 18. Here we go. So we take all the factors of 18 and we put them over. We take all these numbers and we put them over. 1, okay.
Well, you see, I think most people would have just if they'd stopped that. They would have showed that step.
And then we take all those red numbers and we put them over. 2, okay. Sounds like someone's sort of lazy today, Tony. Taking the easy way out. It reminds me of that.
You're supposed to with algebra.
Reminds me of that colleague that said that time when I said about it, and I said, well, so I just rewrite the quadratic formula every time when we're teaching every problem. I rewrite the quadratic formula so they see it over and over again. And that colleague just looked at me like I was, crazy and said, I can't do that. Why not? Why could it? How many problems did he do with the quadratic formula during a class? 6 at most, right? He said he couldn't write that quadratic formula over and over. And I was like, well, then don't complain if your students can't memorize it. So all of these are going to clean up to what?
1, 2, 3, 6, 9, 8.
Okay, so we drop the over 1.
I'm still betting on y'all's intelligence that y'all could get that without writing out the over.
Okay. And next, now we go 1 over 2. Do we already have it listed? No, so let's add it to the list. 2 over 2, that reduces to 1. Do we already have it? 3 over 2. We don't have that, so we better add it to the list. 6 over 2 is 3. 9 over 2. We better add it to the list. That's 4.5. We don't have that listed, so 9 over 2. What about 18 divided by 2? That's 9. Do we already have it? Yeah. So here it is. The finite list of numbers that could possibly be zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 18 possible zeros. out of infinitely many numbers that you could plug in for x, there are only 18 numbers that could possibly make the function equal 0.
Oh, wait. I can't.
There.
Is it A?
A. Remember, was it? I think it's A.
A.
And I'll tell you right now, if you reverse them and you accidentally put the factors of the leading coefficient over the factors of the constant term, that's one of the wrong answers. So be careful there.
You went factors of leading over factors of constant.
They're going to have that as one of the distractors, one of the wrong multiple choice answers. And doing the homework, okay, you got it wrong, well, you can redo it, but you can't do that on the test.
It doesn't tell you a wrong answer, redo it.
Any
I'm assuming y'all
questions?
notice that on the tests and quizzes when you're taking it, when you do a problem, it doesn't say wrong, do it again. I mean, it doesn't say right or wrong until the very end. Any questions on this? Okay. After this, we do some fog and golf stuff. So if you were here the last time, the last 3 problems, let's see, 12 more of those. Oh, that one's going to be pretty fast.
Oh, why don't we do that one? 23 and 2.
Y'all
1
wanna do
times
this one?
23 and 1 times 2. So
Can y'all handle that one, or y'all want us to do it?
I think it's A.
Think it is?
Mhm.
23 over 1. Yeah, it's A. That was easy. Okay, started with 13. It's the fog and golf stuff.
That last step, it's
Yeah.
trying to remind you, because we're going to be doing the inverse function stuff on
one of these graphs.
I like that.
Okay. Well, let's call it quits. Now, before I stop recording, are there any questions that you want recorded? I'll take that as no.